Hello, ladies and gentlemen, and welcome back. I hope you're all doing well and you're ready to finish off our grade 7 Gauss paper. We are on to question at 25, the last question on our 2019 paper. An 8 by 8 by n rectangular prism is made up from 1 by 1 by 1 cubes. Suppose that A is the surface area of this prism, and B is the combined surface area of the 1 by 1 by 1 cubes. So if we actually took it apart and took the surface area of each of these cubes and added that up, that's what B is. What is the sum of the values of n for which B over A is an integer? Okay, so this ratio of different sort of surface areas needs to be an integer. Okay, well, we probably should get a formula for this expression in terms of n. So let's find our surface areas. So if we imagine this cube, it's going to be 8 by 8, so it's going to have sort of a square base. And then we don't know how high it is. It seems like there can be many heights n here. Okay. So here's where knowing the surface area formula for a rectangular prism would be a good idea. So if you have a W by L by H, we might know that the volume is length times width times height. Surface area doesn't come up as much, but it's twice the length times the width. That gives us the area of this rectangle and then the same rectangle on the back, plus twice the width times the height. So that would give us sort of the base here and the top, so 2 copies of that rectangle, plus 2 copies of the other rectangle, length times height. Okay, so that's the surface area. So how's that going to give us a surface area for this particular prism? So 2 times, we'll say 8 by n, and then 8 by another n, and then 2 copies of 8 by 8. Okay, and so when all this is said and done, 16n, 16n, 64 times 2 would be 128. So A, that first surface area, is 32n plus 128. Now we have a nice little formula for that in terms of n. Now for these 1 by 1 cubes, we could use the surface area formula. Or we could say, well, a cube has 6 sides and it's a cube, so it's a 1 by 1 by 1 cube, so they're all going to be 1 by 1 squares on the sides. So 6 times 1 by 1. Each surface area, each cube has a surface area of 6. Okay. Now, what's the total surface area of all the cubes when they're considered individually? Well, how many cubes are there? Well, there's going to be 8 by 8 by n, because those are the dimensions of the prism they make up. And then, so times 6 for that surface area, and so we'll get to 64 times 6. We can grab our calculator, but we don't need to. So 384, and then n. So that's this b value. Okay? And so we need b over a to be an integer. Okay, so 384n over 32n plus 128. One thing I can immediately notice, thanks to these 2 8s, you can definitely divide by at least 32 everywhere. So that'd be 2 times that, so it'd be 12n on top. 32n divided by 32 is just n. 128 divided by 32 is going to be 4. So we really need this expression, 12n over n plus 4, to be an integer. Okay. So how can we approach this? Well, we could, for example, start looking at, try, does n equals 1 work? Oh, yes, it does. Or, oh, no, it doesn't. Then try n equals 2, n equals 3. And see if you can get integers. That's not necessarily the best way to go about doing it, because you're not going to be sure when to stop. But we know that this expression needs to be an integer. So what you could do is you could say, well, maybe the integer that it's equal to is 1, or 2, or 3. And what you'll be able to do is rearrange. So, for example, this first one, multiply by n plus 4 on both sides. And you'll see that 11n must be 4, so n would have to be 4/11ths to get the integer value of 1 for this ratio. And that would go up to a certain point. This, I think, might be a slightly better approach because you can probably sort of limit how big this expression can get. Okay, so for example, notice that the top is 12 and the bottom has just a single n. It's got n plus 4, but if we focus on the n's, okay, the top is roughly 12 times the bottom. Now the bottom's a little bit bigger. And so I think it's probably reasonable to conclude that the most you could ever have this ratio be equal to is 12, and it probably doesn't even reach that. Okay? And so you could just sort of guess and check, make a nice little chart, and that would be fine. But another approach we could do is we could say, well, the problem here is it is really hard to figure out the values of n that make this an integer because one n value changes the bottom and another n value changes the top. It'd be a lot easier to have something like 12 over n plus 4 because then n plus 4 just has to be a factor of 12. Okay? But because we don't know what n is, we don't know the factors of 12n, and so we don't know how to match up n plus 4 exactly. So that's a bit of an issue. Is it something we can fix? Yeah. And so this is a technique. I'm going to go through it very carefully because this is something you don't always see. It is question 25, so this is a little harder. But as I've remarked, the top looks very, very close to 12 times the bottom. What would 12 times the bottom actually look like? Well, you get 12n plus 4 times 12, which would be plus 48. Okay. But I don't have a plus 48 on top. But you can always change things by adding on 0, right? If I add on 0, the top is just 12n. You've just written plus a 0. You haven't changed it. And 0 can be written in a variety of different ways. Okay, this is a technique that I actually teach to my first-year calculus students. The 0 can be written as anything minus anything, and 1 can be written as anything over anything. So it's a great way to change expressions, and it's never too early to learn this. So what would I like? I'd like to see 12n plus 48 on top. I've got 12n plus 0, but 0 can be rewritten as 48 minus 48, because 48 minus 48 is just 0, right? So getting rid of the brackets, this is the expression we have. And if we break up the fractions, we got 12 plus 48 over n plus 4, which I know should just be equal to 12, minus 48 over n plus 4. And so this is 12 minus 48 over n plus 4. So the ratio b over a is always just going to be at least a little less than 12. But now look at that. I've got 48 has to be divisible by n plus 4. N plus 4 needs to divide 48. Well, there's only so many numbers that divide 48. So we could sort of make a list of factors of 48. And as long as we don't forget any of them, we'll be able to figure out the values of n. And then what did they want us to do? We want the sum of the values. Okay? So n plus 4 could be 1, then we could have 2. 3 is a factor of 48, so is 4. 5 isn't. 6 is. 7 isn't. 8 is. 12. Going with 3, you get 16, 24, and 48. And subtracting 4 from these gives us our possible n values. 8, 12, 20, and 44. Okay? But some of these we can ignore because we're talking about an actual geometric shape. How can you have an 8 by 8 by minus 3 prism? You can't. You can't have an 8 by 8 by 0 prism either. Okay? So, if we just wanted n plus 4 to divide 48, these are the possible n's, but we can ignore some of these because we have to remember there's a geometric component to this. N has to be positive. So, these are the only possibilities. And these are the only possible n that will work. So 2 plus 4 plus 8 plus 12 plus 20 plus 44. So those two are 20. That's another 20. That's 40. 6 and 44 is 50. So these two, 40. And then all of it together should be a total of 90. Okay? And if you want to, you can double check what actual value you get for A, what actual value you get for B. But we're sort of beyond that. We don't need that anymore. Okay? So 90 should be our answer. And it's sitting right there. It's going to give us B. Okay? So B is our answer to question 25, and that wraps up our grade 7 Gauss. Now, if you're interested in more grade 7 Gausses, I've got a bunch. You can browse the channel and you can find more. Or if you're looking for a bit more of a challenge, you can try a grade 8 level Gauss. And I'll be going through the grade 8 2019 Gauss next time. But I think that's it for me. So thank you guys so much for watching, and have yourselves a wonderful, wonderful day.